Today we're going to learn how to measure segments and angles, which is topic 1, lesson 1. To begin with, we need to look at 3 undefined terms which are accepted without proof. A point is a location and has no size. When you denote a point, you have a dot with a capital letter next to it, which will be called point A. A line is a straight path that extends in 2 directions with no end. It has no thickness. So here's a line, and there are 3 ways that you can name this line. We can name this line M, which is the little small letter. We can call this line CD, but this time we have to put the line symbol above it. Or we can also name this line DC. It doesn't matter the arrangement of the capital letters as long as you have the line symbol above it. A plane is a flat surface that extends without end. It also has no thickness. To represent a plane, we will see a parallelogram with either 3 points in it, and those points are not on the same line, so we can call this plane XYZ or plane ZYX. It doesn't matter the arrangement of the letters. But we could also call this plane F if it has no point and it's in the bottom right, bottom left, top right, or top left corner. Some terms that we can define using the undefined terms are segment. A segment is part of a line with 2 endpoints and all points between. Here is segment AD. To name segment AD, you use a endpoints and put a bar above it without the arrows, or we can also call this line segment DA with the bar above it. A ray is also part of a line with 1 endpoint and all points in one direction. Here is one ray. A ray is named by its endpoint, so that letter must come first. So therefore we can call this ray DA, but this time the symbol above it is going to be different. It's going to have an arrow on it. But here we have another ray. The endpoint is different. Now the endpoint is A. So now this is ray, got my little symbol. A comes first, which is the endpoint, D. So this is ray AD. These 2 rays are not the same because their endpoints are different. Opposite rays are rays with the same endpoint that lie on the same line. In other words, those opposite rays make what is known as a line. So point A is the endpoint, and ray AD is going in one direction. But then we have another ray with the same endpoint, which is endpoint A, but this time it's going through C. So these 2 rays are different, but they both have the same endpoint, and C, A, and D are on the same line. So we call these opposite rays. Some other defined terms are angle. Angles are formed by 2 rays with the same endpoint called the vertex. So here is an angle, and we can name this angle, since it's a single angle, in 3 different ways. We can name this angle, there's the angle symbol, A, D, M. The vertex, which is point D, is in the middle. We could also name it angle M, D, A. Here again, the vertex is in the middle. We could also name it by its vertex, which is angle D. But there's a 4th way. If there's a number inside of the angle, we could also call this angle 2. When you think about collinear points, points that lie on the same line. So here you have points C, A, and D. They all lie on the same line, so we say that those 3 points are collinear. There are also some postulates that we need to take care of. And a postulate is a statement assumed to be true. The first postulate is the ruler postulate, which deals with the distance of a line segment. Here we have line segment AD, and we want to find the value of it, which is x. And one way that we can find the value of x is to take the two endpoints, 13 and -6, and subtract the two, and then take the absolute value of it. So 13 minus -6 is 19, and the distance from 0 to 19, which is the absolute value, is also 19. But we could also put endpoint A first. Now we want to take the absolute value of -6 minus 13, which is -19, but the absolute value of -19 is also 19. So the distance between point A and D is 19. The protractor postulate is dealing with measuring angles. Here we have 3 angles. The main angle is angle ADM, and then it's broken up into 2 pieces, angle ADT and angle TDM. So what the ruler postulate says is that the measure of angle ADT plus the measure of angle DTM is equal to the measure of angle ADM. So therefore, you're combining 2 smaller angles to get the larger angle. So let's say, for instance, angle ADT is 20 degrees. Angle TDM is 40 degrees. So the measure of the entire angle is going to be 20 plus 40, which is 60 degrees. So the measure of angle ADM is 60 degrees. Congruent segments are segments with the same measure. So here we have segments TJ and segment XY. They both are the same length, the same measure. So we say that they are congruent. So this symbol right here means congruent to. So segment TJ is congruent to segment XY. Once you give each segment a number, a measurement, which is 7 inches, now we say that the 2 segments are equal. So the distance between T and J is equal to the distance between X and Y. Or we could also say the length of TJ is equal to the length of XY. Congruent angles are angles with the same measure. So now you have angle TNC and angle ADM. They both have the same exact symbol inside of them, which is that red arc. So we say that angle TNC is congruent to angle ADM because they have the same measure and they have the exact same symbol. But we could also say that their measures are equal once we know the numbers. So if this is 20 degrees and this angle is 20 degrees, 20 is equal to 20, therefore we say the measure of angle TNC is equal to the measure of angle ADM.